The real takeaway for this question is the framework. If you understand the framework on how to solve questions like this, these questions are going to become very easy to solve. And I will try to explain the framework with the help of a cube. So let's say you have a carton like this, right? And the size of the carton is 3 by 3 by 3, right? So that is about 27 cubic whatever units of volume. If I were to fill 18 cubic units of sand in it, then I can easily fill that in the sand, and we can even calculate how high the sand will go, because we know that the sand will also take the shape of the carton itself, and it will go the bottom of the carton will be 9, so it will go about 2 in the height to give you 18 cubic volume, right? So this is all good when whatever you are pouring into the carton is malleable, can take any shape and form. However, when you are trying to fit a can inside of a carton, the can cannot change its volume, and here is where it gets tricky. All right, so one of the things that immediately comes to your mind, and one of the thumb rule that everybody has, is if the volume of the carton is more than the volume of whatever we are filling inside it, then it will fit, right? However, that is not really always the case. Sometimes, for example, let's take this particular box, right? And let's call it 224. So the volume of this particular box is 16 cubic units, and it is definitely less than 27. However, as you can easily see, this box cannot fit because the maximum size on the carton is 3. So the number of boxes that can fit in the cube or the carton is technically 0. So what does that tell us? That tells us that volume is not really that important when you are taking two solid shapes into account. You need to know the dimensions. So that is my rule number 1 of the framework. You must know the dimensions. Now here is another layer of difficulty that GMAT introduces in questions like this. Let us assume that this carton was not, currently we are assuming that this carton had no thickness. Let's assume that this carton had a little bit of thickness to it, right? Let's call it 0.5 in one way. So that makes each of these sides as 2, 2, 2, right? All of a sudden, the space that you can fill inside the carton is much smaller. And hence, without knowing the internal dimensions of the carton, the solid that you're putting things into, you have to know the internal dimensions of it, right? So that is my second postulate. Must know internal dimensions of, I will call it outer container. In this case, it is the carton, right? Here is the can that you're trying to put inside the carton could also have two dimensions, right? So I gave you this 2 to 2, but it could be this thick, right? Which would make it difficult for it to fit even slightly inside the carton itself. So what you should know is the external dimensions of the can or the items that you are trying to fit in the container. Without knowing the external dimensions, you cannot find the answer. So must know external dimensions of the inner container. In this case, that is a can. And finally, volume of these two. So people can think like, it is not given that the can cannot be crushed, And there are some people who think that they can just crush the can and try to figure out how many cans can fit in, or they can do a lot of that stuff. Unless it is given very specifically that you can change the volume or crush the can or crush the object or something of that sort, the assumption is the volume of either the container, outer container, or the inner container doesn't change, right? So volumes, dimensions do not change unless given otherwise. These are the four most important postulates to solve these questions. Once you have solved this question and with this postulate, once you understand this postulate, solving question like this, and as you can see, about 40% people get this question wrong because they don't know how to approach. Once you understand this approach, once you understand this postulate, you will get to a point where you will get most of these questions right. And now let's solve this question, right? So I must know the dimensions, outer dimensions of I must know the internal dimensions of the outer container, which is the carton. I have been given the interior volume, not the interior dimensions of the carton. So this is not given to me yet. In the second statement, I have been given the exterior dimension of the can, but still not the interior dimension of the carton. When I combine these two, I am still not given the internal dimension of the container. Easily my answer is E, because all of these postulates are not satisfied, and hence the answer will be E to this question. Quickly, these takeaways for your notes, you can always go back to review this video. It is public after the recording, after the live session. Always we need the dimensions. Volume is not enough. For the enclosing container, you need internal dimensions. Just the external dimension is not enough, or one of the dimensions is not enough. For the container or box that you're putting inside the container, you need the external dimensions. Internal dimensions don't matter to us. And finally, the volume does not change. If you follow all of these steps, the reasoning and answer to questions like this become very, very straightforward. I will take a pause here and see if there are any questions in the chat box before we go to the next question, where we are going to figure out how to solve certain things with less amount of time. Okay, doesn't look like there are any questions, so let's get started with this one. I will again give 2 minutes for all of you to solve this question if you haven't already. If you have solved this question, please post your answers in the chat box, and we will get started with 3 approaches. If you have solved this question, please put your answers in the chat box. Let's see if you can get it right. About 30% people get it wrong. You're welcome, Sam. Okay, exactly at 11:12 I will start solving this question. Another minute for you to actually solve it, so that you can appreciate the amount of calculation that may be required in questions like this. And obviously I'm going to talk about how you can save time in questions like this by changing your approach or adjusting your approach a little bit. And we will do some more questions similar to this, where if you actually solve the traditional method, you will end up spending a lot of time. All right, so let's get started. I will take 3 approaches to solve this question. One is completely reasoning based, but there will be some numbers that I will write down, and there would be some mental calculation that I will do. However, I will show it to you and you will realize it's not really that big of a mental calculation. expressing it as fractions, on how to solve this question when you are expressing the questions like this in fractions, and then finally actual calculations that somebody will do. This is like the worst method to solve this question because it is the most time consuming. I will also talk about some of the mistakes people make in questions like this so that you can avoid those mistakes in future, because there are mistakes that are being made. Right, so first I'll talk about the mistakes, then I will go through the methods. So the first mistake everybody that I have known initially makes is ignoring the word magnitude in the problem. Magnitude means just the change, just the magnitude of the change. It doesn't matter what the sign of the change is. A lot of people just assume that from this to this, since it is negative, negative is already small, and since it's small, it cannot be the greatest, since we have to find something greatest, and hence I don't need to actually find this particular change. Since it is given the magnitude, you have to do the right thing by whether it's going from top to bottom, which is decreasing, or it is going increasing direction. You have to use and find the percentage changes in all of them, right? The second very common mistake here is the calculation mistake. If you write some of these things down or don't do that correctly, don't do the fractions correctly, you will end up making a mistake, and which would cost you the question. And it is not really that difficult question, only about 30% people get this wrong. And finally, choosing the incorrect denominator, and this is very important and fundamental mistake people often make. When you are calculating anything that is creating a percentage change, always take the current year versus the previous year. So whichever change you are, whatever change you are, percentage change you are measuring, the previous year or the previous day is the more important. Taking the current year will cause an issue. Similarly, when you are taking percentage change or percentage profit, it is always measured with respect to the cost price rather than the sell price, because that is the initial price of the good, and then you do a sell price, which is the new price. Okay, so this mistake is very fundamental. If you make this mistake, then you will probably not get this question right. Okay, so now let's go into the solution of this problem, and we will start with the reasoning. I will, just so that I don't make any mistakes, I am going to translate this question by putting these values down, so that for my calculations I don't have to go and refer back to this figure again and again, right? And let's read the question a little bit. We are given that there are these are the number of questions that somebody is assembling in the 6 consecutive days, and we have to find the percentage change of greatest magnitude. Okay, so on day 1 it was about 20, on day 2 only 12. So I'm going to write this 12 here because there is a decrease here and I want to just make sure I know about it. The next day it is 18, the next day it is again down to 10, then it goes to 16, and then it goes down to 8, right? And remember, I said I am going to solve it with a reasoning based approach. So what I'm going to do here is do 2 things. One, think about my starting point and what is the 50% value of it. So for 20, my 50% value is 10, and take the difference between the old value and the new value and measure if that is more or less. So 20 minus 12 is 8. 8 is less than 10. So this change is less than 50%. All right. 12 minus 18 is 6, and the starting point is 6. The 50% of 12 is 6. 12 minus 18 is 6, the magnitude of it. And so the change is exactly 50%, right? Similarly, if I do here, the 50% of 18 is 9, and the change is 8, which is less than 9. So we have less than 50% here. When I go 10 to 16, the 50% value is 5, and the change 10 minus 16 is 6, which is greater than 5. So this is greater than 50%. and then the last you will again find it as 50%. Now, as you can see, very easily I can see that this is less than 50% equal to less than. This is the only one that is greater than 50%, and hence my choice D, which is 4 to 5, is the greatest magnitude, right? Now, this approach is really good, and 80% of the times it would yield you result. Sometimes it may not, because I may have more than one choices that are greater than 50%, for example, and that is fine. In that case, you would have two choices to compare rather than calculating all of the 5 choices. I'll take a pause here and see if there are any questions around this one. Anisha is asking a question. Is the video hazy only at my end? Are you guys having a problem with the video also? Could somebody please reply? Abhirup or San, can you reply to the question? Okay, so Anisha, maybe you adjust the width, or the if you are on full screen, maybe that is what is causing the issue. Maybe you want to reduce the size of the video, and that would help. I'm not sure why that would be the why that would be the issue, but maybe it's the screen resolution or something of that sort. All right, so we are going to, since there are no other questions, we are going to go to the step number 2 of this approach, right? We saved a lot of time doing this approach because this you can do within 30 seconds. Let's assume this approach did not occur to you, right? And it is very possible it occurs to after you've done lots and lots of problems. These kind of approaches occur to you, but it is absolutely fine. The next approach is the fractions approach, and here I'm just going to calculate the fraction, the change divided by the initial year or the previous day. So for the first day to day 2, my change is 8 divided by 20. For 12 to 18, my change is 6 divided by 12. Similarly, 18 by 10, so my change is 8 divided by 18, the start of the year. Then 10 minus 6 is 6. 16 minus 10 is 6 divided by 10, the start point. And then finally 8 divided by 16. Now the first instinct would be calculations, and we will go to that in the third method. Here I would say stop, right? Look at these fractions. They are arranged in a slightly beautiful fashion, and you don't have to calculate out all of them. You know the numerators for these are same. If the numerator is same and denominator is the highest, that number becomes the lowest. If the denominator is the lowest, that number becomes the highest. So for these, find the number that has the lowest denominator. And which number is that? Right? 20, 18 and 16. So this number. So I need to consider only this number because this is already the greatest of the 3 I have chosen. Similarly, the numerator here is also same, and this has the lowest denominator. So I really need to actually calculate only these two rather than all of them, and this becomes 60%, 10 divided by 60, and this is 50%. Very easy calculations, and you can solve it within another 10 seconds. All right, so again the answer is D, and the final method is actually the calculations. So 8 by 20, you will get about 40%. 6 by 12, you will get 50%. 8 by 18 is what will waste most of your time, as you will get about 44.4% here. The rest 60% and 50%. The trick was, if you could eliminate calculation around this 44%, you would have saved time, and you could have done that by just measuring the fractions rather than actually calculating them one at a time. I will take a pause here. We have already talked about the mistakes here. So I'll take a pause here, see if there are any questions. I think the question is very straightforward. And if there are no questions, then I will go to the next problem, which is a profit and loss problem. And again, calculation is the key here. All right. Looks like there are no questions. So we will start with this problem. I will give you maybe one and a half minute to solve this problem, or let's take 2 minutes to solve this problem. If you want, you can take 2 minutes to solve this problem. It's again very wordy and long sentences, but when we solve it, you will see that depending on which method you choose, it could be very long or it could be very less. And I will solve this question with 3 different approaches with increasing amount of time needed. Meanwhile, if somebody had a question on the previous or any other questions, please feel free. I am available on the chat to answer the questions. Okay, another minute and then we will start talking about, we will start looking at the solutions. All right, so let's start. Let me break this down, the question down first, so that you guys have a clear idea of what is being asked, right? So there are 60 cameras. So let me just write the 60 here, and out of which, sorry, there are 60 cameras and they are being sold at 250. So selling price is 250, and it's given that the selling price marks 20% markup over the cost price. So I'm going to write this as 1.2C, where C is my cost price, right? And what is also given to us is that 6 were never sold, which means the photographer actually just, or the dealer actually just paid the cost price to get the cameras, but he was not able to sell them. So he returned it to the company, but he got only 50% of the money back. So he still lost about 50% of the money. So I'm going to distribute this 6, they were never sold. And then we of course know that 54 were sold at the cost price. And the question is asking us, what is the approximate profit? Now you can see that only 6 were not sold, 54 were sold at a decent amount. So there is definitely not loss here. So I can likely just cancel these off and think about anything else for that matters. Now, now here comes the method number 1. Okay, this is very reasoning based method rather than actually solving the question. I will try to see if I can fit the method number 1 here, and then if not, then we'll move to the other space, right? So I will start with some explanation which is not related to the question itself, just so that you understand how I'm going to reason it, and then we will get into the question. So let's say if I was losing $1 on one item and I was gaining $0.5 on another item. So if I sold one of this, to offset this loss of $1, how many of this $0.5 profit one I would have to sell to make it 0 loss and 0 profit, right? The answer is 2. If I sell 2 of this, then the amount of money I gain, which is be $1, will make up for the loss, which is the loss of $1, right? This is the concept I am going to apply to this particular problem to get to the answer very quickly. So again, I have 60 and 6 went for a loss because I was not able to sell them and my loss was 50%, right? On my cost price. It doesn't matter what my cost price it is at this point. I know that the loss was 55%. You can also write it as 0.5C if you want, but let it be 50%, right? And here my gain is 20%. So here I'm getting a gain of 20% for each of the 54 other cameras I have sold. Now, if I sell one at a 50% loss, how many do I have to sell at 20% gain to make it 0? That's the first step of my thinking here. And let's assume I sell 1, which is minus 50. I would have to sell 2.5 here. So 2.5 multiplied by 20% would be 50%. So minus 50 plus 50, it will come together to be 0. So for 1 sold at minus 50% loss, I would have to sell 2.5 at 20% profit. For 6 sold, because we are given 6 here, right? For 6 sold at 50% loss, I would have to do 2.5 multiplied by 6 equals 15 at 20% loss. So I know that at 15 sold, I am at 0 profit or 0 loss. For the rest, it is pure profit, right? How much are the remaining ones? 54 minus 15. These are the remaining ones on which I am making pure profit. Now, to be honest, when I am solving questions like this in GMAT, 39 is a multiple of 3. 39 is a multiple of 13, and I see only one number with 13% profit. I would likely just stop here, put 13% profit and move on, right? Question solved. However, just to demonstrate the question and get the 13% profit answer, I already received 39. So for 39 devices, I am getting 20% profit, right? So that is 0.2 profit divided by total number of devices I have, which is 60. When you solve it, you will get 0.13 multiplied by 100. That is 13% profit. So this is method number 1. As you see, it was purely reasoning based. I first figure out at what point they become 0 profit or 0 loss. And then I moved on to find, okay, what will be my pure profit? Remember, the percentage would always be calculated at the base, which is the 60, which is the 60 cameras, not 30. The method 2 is another one of those methods that would be applicable in this case and get you the answer very quickly, but it will require a little bit of calculation. And this is called the weighted average method. So average profit or average loss is just the weighted average of individual profits and individual losses. That's what this formula says, right? So I have 0.2 profit made on 54 devices or 54 cameras minus 0.5 loss made on 6 devices. So this is the overall profit minus loss divided by total number of devices I have, which is 60. This will give 0.13 if you do the calculation very quickly, and that would be 13%. The problem with this approach is a lot of you probably do not know the weighted average formula. Now you know. You can actually practice it in a lot of other profit and loss questions. You can actually practice it in a lot of mixtures question as well, where you're mixing water and another another liquid and things like that, because the same formula applies there as well when calculating liquids. I will get to that, Abhiram. I will get to that, right? So that's a very good question, and this is the exact question you need to keep asking when you see any kind of reasoning method, like how do I get to that, right? What kind of thinking I would have to get to that method. So finally, method number 3 is your overall calculation method. This is the longest method of them all. I am not going to solve it completely. I assure you the answer would still be 13%. However, I am going to just talk about the approach. And the reason you should know method number 3 as well as 1 and 2 is because in case you're stuck, in case method 1 or method 2 does not occur to you, method number 3 is calculation intensive and you can still follow. And I do have a trick that I think you must know, and it will get repeated in one of the other questions we do to simplify the calculation, right? So in method number 3, we know that the cost price, the selling price is 1.2 times C, and it is actually 250, which means C is equal to 250 divided by 1.2, right? Now total revenue for the dealer is the 54 cameras he sold, right? So that is 54 multiplied by 250, right? Plus the 50% revenue he gets back from the cameras he couldn't sold, but the company actually gave him 50% back. So that is the money coming in also, right? So 0.5 multiplied by the cost price, which was 250 divided by 1.2 multiplied by the 6 cameras he gets back. So this is the total money coming in. Now the total money going out was his total cost, which is nothing but C multiplied by 60 cameras, which is 250 multiplied by 60 divided by 1.2, because this is our cost price multiplied by 60, right? The percentage profit or loss would be total revenue minus total cost divided by total cost. So let's write that down as well. So 54 multiplied by 250 plus 0.5 multiplied by 250 times 6 by 1.2 minus 250 into 60 by 1.2 divided by total cost into 60. Now here is one thing that is very important, and I hope you have noticed this one thing in method number 1 and method number 2. The selling price doesn't matter, and the cost price technically also doesn't matter. All that matters is the percentages, because as you can see, all of this kind of cancels out. 250 cancels out. And here is another pointer that I hope you notice here. I did not do the calculations right here when I was calculating the revenue and cost. I just kept the expression as is, and you will see the exact same thing I will do in one of the other questions to reduce the math involved. And what that resulted in is, at the end, I took out this big number, right? 250 is a big number. I took it out of the calculation completely. Now I can even multiply 1.2, I can even divide it by 60, and you would see that the things are starting to become very easily manageable in terms of calculation. Rather than calculating up front, wait till the end so that you can see if you can cancel off. If you can see here, 54 is just not 6 tens are 60 and 6 nines are 54. So there is divisibility here, right? 6, there is 1.2, 6 divided by 1.2 is kind of half, so you can easily calculate that ratio also. This is already 60, and 60 would cancel off. So when you simplify it, it will become very easy to calculate, and that is the other tip I have. It will come out to be 0.13, which is same as 13% profit. Now I want to address Abhiram's question just after I discuss the takeaways, right? So, in questions like this, where you have selling price, profit, all of that, always start with cost price. Your cost price is your basis. If you have a way to reach at the cost price, you will be able to solve the question. You may take the longer method, or you may take the smaller method, but you will always solve the question. Right. The other thing, if you notice, we did not need the selling price at all because it cancelled out in the end. So all was given is the cost price because we were already given ratios and profit based on the cost price, 20% markup and 50% of the initial cost, right? And then finally understanding how the averages work, and this is the answer to Abhiram's question, is the reason I started with approach number one initially is because I knew that I have to calculate average when I have some numbers, which are the 54 numbers, 54 cameras being sold at 20% profit. It is increasing my profit high, and there are some numbers which are 50% loss and they are reducing my sum or profit down. There has to be an average, and where would that average lie? That is the first thing that comes into my mind when I'm solving these questions. And of course it comes with practice, but now that I have told you, you should think about the same thing. Is there a way I can figure out where would my average be? And to figure that out, let me go back. I started with figuring out when will they equate, because at the point they equate, I am at zero profit or zero loss. After that it is pure profit. So I know after that I will make a pure profit. Now for the pure profit I need to do some calculation, right? So I have figured out what is the 0 point, the neutral point, and then there is pure profit. It could have been the other way around, right, as well, depending on what the question is, where the loss is more than the profit. But if you apply the same approach, you would figure out, okay, these numbers are pulling the loss down, these numbers are increasing the loss up. Eventually there has to be a point where they are zero, and how much down I am below zero is the real question, is what the question is asking. It's what the average or approximate percent of dealer's cost would be, right? Does that answer your question, Abhiram, or is it still unclear? Alright, while we wait for Abhiram's response, I will open up this question. It is the maximum possible length of the longest piece of a rope, right? This is again a little bit of calculation intensive question, and I want to point out a certain amount of things here. So I will give you another 2 minutes, maybe 1.5 minutes. It shouldn't take that long. If you know the statistics formulas to apply, and if you have gone through my maximizing and minimizing video, it should be very, very quick. If you haven't gone through my maximizing, minimizing video, that is okay. Attempt it anyway. I will put a link to my maximizing, minimizing video later on, where we are going to use some of those fundamentals in solving this problem. And we will also talk about how can we reduce calculations using the same technique that we did in the previous question. All right, another 30 seconds and then we will start. All right, so now let's get started with solving this particular question, right? So we are given the 7 pieces of rope. We are giving the average, and we are given that there is a median, right? And we are also given a very slightly complicated relationship between the smallest piece and the largest piece, and that is all fine. The most important thing is we are asked to find the maximum possible length in these pieces of rope. So the first step to solve these questions and any of these statistics question is to first write down the 7 things, because it's given there are 7 items, right? And also we assume an order. You can assume ascending order, you can assume descending order, but always assume an order, because median is defined after you have arranged the pieces in particular order, right? So let me start with the 7 pieces. 1, 2, 3, 4, 5, 6, 7. And I will start writing down what has been given to me. So first, I have been given a median, has to be the middle value. The middle value has to be the value number 4, and that is 84. So this is given to me, right? I also said that these are all in ascending order. So I have greater than equal to sign, and this is important just so that I don't assume that they all have to be different and unequal all the same time. They could be equal and it is still an ascending order, right? I am given that this value is, let's call it small s, and if I know that small s, I know this big S is 4 times the small s plus 14. So there is a constraint on the maximum value, and that constraint is driven by my smallest value. And finally, I am given the average is 68, which means the sum is 68 multiplied by 7, right? Now, the first tendency here would be sum equals 68 multiplied by 7 equal to 476, right? Calculate that and go from here. This is where I want to refer back to the problem we just did. Don't do that. Let it be 68 multiplied by 7, and I will tell you why. I am noticing some very important patterns here that I want to point out so that you start thinking in these same patterns when you're solving questions. You see this 68 multiplied by 7. Notice this. 14 is a multiple of 7. 84 is a multiple of 7. 12 multiplied by 7 is 84. So I have these multiples of 7 kind of pollinated everywhere in the question, which means there is likelihood that 7 will cancel off. So let's hold off in actually doing the calculation and just keep it as 68 multiplied by 7 for now. All right. Now we are going to start applying some of the maxima and minimum, maximizing and minimizing strategy. And by doing this, let's call this S2, this S3, this is S4, and this is S5. Fine. All right. So we know the sum is given to us. I am going to combine these two here. Plus 84 plus S4 plus S5 is, and plus the maxima, which is 4s plus 14, maximum value, equals 68 multiplied by 7. Note that I haven't changed it, right? And I can rewrite this in a way that it makes sense to me, right? But hold on. First, I am going to just write 4s plus 14, which is my maximum value, equals 68 multiplied by 7 minus 84, which is 12 multiplied by 7. I will rewrite it, minus S2 plus S3 minus S4 plus S5 and minus S. Okay. If I have to maximize this, I have to technically maximize the S. So let this S be there. It doesn't matter. You can even bring it back here. I have to minimize this sum. to maximize the overall value, the maximum value. If I cannot minimize this sum, then I cannot find the maximum value. So this is the one of the postulates in this maximizing strategies. Once you put them in an equation, all you have to do is express the equation in terms of the sum, and whatever is in the subtraction, you have to minimize it to maximize this side of the equation. Or if we have to find the minimum here, then you would maximize these. Now what would be the minimum? So we have to find the minimum values for these two, is basically what I'm saying. Now what is the minimum value of S2? S2's minimum value would be nothing but S, right? It can only go up to S, because if it goes below S, then our ascending order gets disrupted because we have a new lower value, right? So this will become S and this will become S. I'm just going to write it here. S3 similarly, the minimum value is S. For the minimum value of S4 and S5, it is the median itself. If S4 goes below the median, then again my arrangement gets screwed up. I have arranged things in the in a certain order, and the middle value is always the median. So if S4 is actually less than my middle value, then my S4 is actually the median, not my middle value, right? So here I have 84 and 84 as my sum, right? Any questions so far? Okay, all right. So now I'm going to rearrange certain things here. I'm going to take these S's, all of these S's here. So I get 7S plus 14. This is the maximum. This is kind of the maximizing the equation already, right? Again, notice multiple of 7, right? Equal to 68 multiplied by 7 minus 84 minus 84 minus 84. So 3 times 84, I am going to write it 3 times 12 times 7. It is that time of the solution where I have to kind of start expressing everything in 7, and which basically says 7s equal to 68 into 7 minus 3 into 12 into 7. I take the 14 on this side, that becomes 2 into 7, and I cancel off 7 very quickly. 12 3s are 36 plus 2 8, so this becomes 68 minus 38, that is 30, right? Now this is the S. As you can see, none of these values are answer, because the question asks you the maximum possible value of the longest piece of rope, and you have just calculated the smallest piece. The longest piece is 4s plus 14, which will be 134. So if you had not done what I did, which is keep the 7 as separate and keep them expressed as multiples of 7, this would have been immense amount of calculation, and GMAT usually does not give these immense amount of calculations. It's very simple problem. The maximizing and minimizing strategy was very basic. There was nothing big about it. The big thing was, if you chose to actually calculate it at 476, you would have run into a lot of problems and probably could have made mistakes in solving the problem as well. I hope this is clear to you and you found it valuable. I am going to take a pause here, put the next question up, and see if there are any questions on this particular one. And I will meanwhile talk about the takeaways, right? So it is important to learn the statistics formulas. This was not really anything beyond the basics. Think about minimizing the calculations, and one way to minimize the calculations in GMAT is not to kind of solve them one by one and then get everything together. Keep them separated out in their factors and things like that. It becomes easier. And also understand the minimizing and maximizing strategies. They sound scary, but they are not really. There is a method to the madness around minimizing and maximizing strategies, and if you kind of go through that video and work a few problems, you will get there in no time. All right, So now we are going to talk about this question, and this will be the last question. About 50% people get this particular question wrong. I had another question planned, I believe a permutations question, but we will take it up in the next session. I will give you 1.5, maybe 1 minute to solve this question. This question should not take more than 1 minute. However, people still get this wrong. And what we are going to do is, instead of solving this question, first I will solve a modified question first, then another modified question first, and you would understand the method and the logic behind solving this question very quickly, and then we will solve this question. All right, so your time starts now. Meanwhile, if you have any questions, please feel free to ask. Glad you found them helpful. Okay, all right, so let's talk about how to solve questions like this. And let me tell you, from an expert's eye, I would look at this question and immediately go to an answer choice without actually thinking about it. And somebody like GMAT could take advantage of that. However, in this case, it would be tough, right, in these answer choices. So I'm given negative values and positive values, and I'm asked least possible value of the product, right? The least value has to be negative. San, thank for answering the question. Appreciate it. And but think about, why could it not be negative? Why would it be 0? You have, when you have something like -2, 0, and 2, what is the least possible value of the product? It's -4, right? It's not -2 into 0, which is 0. It is -4 because 0 is actually greater than -4. So as soon as I read this question, I know least possible value would be negative, and then I would be looking for least possible values which are negative here. This is a positive quantity because it's raised to an even power. This is also a positive quantity. This is 0, and I kind of know that it won't be 0. Answer would be one of these, and I would tend to mark this one because I know this is the smallest possible compared to -10 to the power of 19 and between -10 to the power of 20. This is the smallest one. Now this is the reasoning based solution for somebody who has an expert eye and who has solved a lot of those questions, and you may not be able to solve the question that way, and that is perfectly fine. Let me modify the question a little bit for you and see if we can come to the answer, right? So let's assume that the question had, and forget about these answer choices, let's assume that the question had asked us about -10 and 11 inclusive. One of the reasons this question becomes very confusing is because you're given -10 and you're given +10, and that kind of exudes symmetry and creates issues. So we are asked to find the least value of the product of these 20 integers, right? And remember, the repetitions are allowed. If the repetitions were not allowed, then the product will be 0 because 0 is one of them, right? The consecutive integers. So repetitions is involved, is allowed. So I know it has to be negative. So one way to think about it is I could use -10 19 times, and I could do multiplied by 11 once, because I have to have the negative numbers odd number of times. If I have the negative number even number of times, then it becomes positive, right? Minus multiplied by minus is positive, minus multiplied by minus multiplied by minus multiplied by minus is also positive. So the question is testing your understanding of multiplication of negative numbers. So this is one possibility. The other possibility is I take the largest positive number and multiply by the least number, right? So to solve question like this, think about what will give you the biggest magnitude, right? And start there. So the biggest magnitude, forget about the most negative least, the least number would be equal to minus sign of the biggest possible magnitude. So you have to find the biggest possible magnitude and a way to get a minus sign in front of it during the product. That's the approach here. Okay, so technically my biggest magnitude would be 11 to the power of 20. If I choose all the numbers as 11, then that will be my biggest number, right? However, that is all positive. I have to find a way to find the biggest number, but I have to get a negative number in here, right? So the other option would be 11 to the power of 19 multiplied by 10. This will be the biggest magnitude. We have 19 here and we have minus 10 here to get to the least possible number. And why am I caring about the magnitude? Amongst, let's say I have 7, right? If 7 is the largest number, then minus 7 would be the least number. So if I had only two numbers, let's just say I was picking only two numbers, right? So I had a possibility of picking 11 and 11, which will be 121, but it cannot be negative because 11 is only on the positive side, not on the negative side. However, 11 multiplied by 10 is 110, and I could have minus 10 here to give minus 110, which will be the least number. Any other number, minus 10 multiplied by minus 10 or 10 multiplied by minus 10 will be 100, right? So the trick here is to find the largest magnitude along with a negative sign. If you find that, then you find the least possible value of the product. In this case, it would be 11 to the power of 19 multiplied by minus 10. You have to have a negative number so that you can get the least possible value of the product. Now let's shift it around, right? Instead of minus 10 to 11, let's assume you had minus 11 to 10. If you had minus 11 to 10, now if you do minus 11 to the power of 20, you still get positive 11 to the power of 20 because the negative number when multiplied even times goes away. So this is not a possible, this is the maximum number possible, but not the least value possible. So to find the least value possible, you will again take the magnitude, the maximum magnitude, multiplied it by 19. So now, raised to the power of 19, which is multiplied 19 times, so that you have the negative fraction, and then you take the most possible, biggest possible positive value, and this will be your maximum value in this case, right? When you understand this fundamental, the answer to the question that is actually given to you becomes very easy. You are given minus 10 and 10, right? So again, you have to take one of the values, the biggest possible values, 19 times and another value 1 time, but make sure that the negative stays, right? So you will take minus 10 19 times multiplied by 10 1 time, or you could take 10 19 times multiplied by minus 10 1 time. This will give you minus 10 to the power of 19 into 10, which is nothing but minus 10 to the power of 20. This is also give you 10 to the power of 19 multiplied by minus 10, which is nothing but minus 10 to the power of 20. Hence, this be the result. Okay. So the main reason why people make mistake in this question is the following. One, they don't understand the meaning of least possible value, right? They assume the value to be 0. If the repetition was not allowed, the least possible value absolutely will be 0, because the repetition is not allowed and 0 is one of the values. However, since the repetition is allowed, you can literally take minus 10, minus 10, minus 10 as many times as possible. The second option, the second part of the question is maximizing the possible value, which means maximizing the magnitude first and then making sure somehow that you have the biggest possible negative number there, so that you always get a negative sign at the end. What that means is minus 10 to the power of 20 cannot be the answer, because this would really mean 10 to the power of 20, and it is a positive highest number, not the negative highest number, and the least value would always be negative. I will take a pause here and see if there are any questions. This was slightly more complicated question, and as you can imagine, about 50% people get this question wrong. If there are no questions, I would love to get some feedback on how I can improve and make it more valuable to all of you. And that's it. I think we are at time for today's session. Thank you all for joining. I hope you found this helpful. Please do not forget to like the video if you did find it helpful, and subscribe to my channel. We will meet again next Saturday approximately the same time with more questions, starting with this particular question, which is OG question number 245 or PS05140. The A would be the max possible value. Correct. Yes, Sam. Absolutely. Yep. I wish I could solve them. Abhiram, I can only try. Given the amount of methods I had and explanation, I want to make sure everybody gets the most out of it. So I can definitely try next time to solve more questions faster. However, it is important that I kind of talk about all the different ways and what is the thought process and everything. That takes me a little bit of time, but I will try to kind of balance better next time. All right, any other questions? All right, everybody, thank you everybody that you joined, you spent time with me. I hope you have a great weekend. If there are any additional questions on the questions we solved, you can either reach to me via the WhatsApp group, the Facebook group, or post a comment on this video itself, and I will get back to you. If there are any questions that you want me to solve next time, please send me the question number, the PS or DS number, so that I can take that into account in the next set of questions I'm planning for the next week. Thank you and have a great weekend. Bye. Sounds good, San. I will look into some of the geometry questions and comparisons questions as well.